So we're told that this rectangular box is inscribed in a sphere. So I'll try to kind of draw this in 3 dimensions so you can kind of visualize what's happening. So it's going to be something like that. Maybe I'll draw this as a solid line. So we have this rectangular box. So I'm going to label the sides as length L, width, and height. And then we also have to figure out the radius or the diameter of the sphere to kind of answer that question. And what you'll see is if you connect these opposite vertices, that's your diameter. So that's your D, or the diameter of the sphere. And that's also the diagonal of this rectangular box. And if we apply the Pythagorean theorem, and some of you might already know this result, this is the length of a diagonal, the longest length inside a 3-dimensional rectangular box. And this is how it's related. I'm not going to go over how this comes about, but this is an important result that you should already know. So that's the first relationship. And then we're given these 2 other conditions, which is, I'll start with this, the sum of the lengths of all of its edges. So there are 12 edges here. 4 are lengths, 4 widths, and 4 height, and that we're told that adds up to 144. So if I divide both sides by 4, simplify this, we get equal to 36. Now the other condition is that the surface area, and again, most of you are probably familiar with that expression, the outside surface area of a rectangular box is this, and that's given to us as 846. So these are 2 relationships. I need to get to D somehow because that's related to the volume. So the key thing you have to notice, you have to pay attention to that, this, and this. And that link comes from L plus W plus H square. And some of you might already know. I mean, I also sometimes forget, so sometimes I'll try to just do it quickly. So that's what it turns out. And we're given that, which is 36 square. This is our D square. And then that piece is 846. So from this, we can figure out what the diameter is. So I'll do this calculation. You can use the calculator for this one. This is just a simple computation. So I get D squared is 450. We need to figure out the volume. So volume is 4/3 pi r cube, and I'm going to rewrite this in terms of diameter. Radius is half the diameter, so this would be D cube over 8, or 1/6 pi D cube. Now D squared is 450. So I'll split it into D square and then D, which will be square root of 450. So I just have to simplify that. Square root of 450 is 9 times 50, or 9 times 25 times 2. So this is going to be 3 times 5 root 2. So that's 1/6. 3 times 5 root 2. Simplify 225. So I just have to do 225 times 5. Again, you can either do it by hand. I get 1125. So this whole thing simplifies to 1125 pi, and don't forget the root 2. And that's same as answer choice A. So the key was this. I had kind of seen these in similar problems before, and maybe this is where practice helps. If you've seen something similar, you kind of expect a relationship between these 2 quantities. And that was clear once you recognize this identity. I think it would be much harder if you had no idea about this connection to do this question in the exam under pressure. And I think this is where practice probably will help you kind of be prepared for these variations. So to summarize, the answer is A.